time that we have together. I think it would be good to go ahead and get started. Our fearless leader for today, or for this cluster, Amy, was not able to make it today. She sends her regrets, but she left the call in able hands. So I'm Megan Carter, I'm ESIP's community director, and I'm here to just kick off this session. I'll be with you for the first 10 minutes or so of just announcements for this cluster. From the ESIP side, we wanted to report that the ESIP summer meeting early registration deadline is this Wednesday. The meeting's coming up. It starts 3 weeks from today. We're very excited about the community contributed content, the plenaries that we'll have, the many networking opportunities that we hope you'll join into. And for one last time, I'll paste in the chat a link to our meeting notes, and you can see a link there to the summer meeting information. Amy also wanted us to convey that the agenda for the cloud optimized data session that will be taking place during the summer meeting has been finalized. It'll be shared very soon with all of you to take a look at. And also we very much hope that you'll help to spread the word to your networks about this important session that will be held. So with that, I would ask this good crowd that we have gathered here today, is there anybody else who has anything they'd like to share announcement-wise from your networks? You can feel free to pop it in the chat or unmute yourself. All right, well, if you think of anything, feel free to pop it into the chat. I will now pass it over to one of the co-chairs for this cluster, Sudhir, to introduce our presentation for today.
Hi, thanks, Megan. So welcome, everyone. So today we have a special talk coming from our weather service. So Steve and then Shane, so they'll talk about the EDR. So that's the effort that's run through the OGC. So they'll talk a little bit about the background of the EDR and some of the collaborative effort and the capabilities that the EDR is bringing, so that there'll be some much more uses of the EDR as well. So I'll pass it to Steve.
Okay, thanks, Sudhir. Can you hear me okay?
Yep.
Yes.
Okay, very good. All right. Well, definitely appreciate the opportunity to share with everyone the work that's going on in OGC. The first slide you see here is actually taken from one of the blogs on the OGC website that focuses on EDR. This was basically in response to one of the last planned sprints/workshops that we had before positioning EDR to be accepted as an OGC standard. And this was back from March of 2020, right as COVID was hitting. And it was going to be, I was essentially going to have this be at the Weather Service facility in Silver Spring, Maryland. Obviously, we couldn't do any of that. And so there were a lot of challenges in getting support from every continent to support this sprint exercise. So we ended up having both early morning and late evening debrief sessions on the fine work that was going on within the EDR specification. So the blog kind of talks about the challenges of using video conferencing technology and the spans of time to achieve the goals of the sprint exercise. So encourage you guys to reach out for that. Next slide. So what we're going to do today is talk a little bit about what the OGC API, EDR API, what issue that is trying to solve. We'll talk a little bit about how it works. It's definitely a paradigm shift away from the 2D world. EDR has benefits for both users and providers. I will tell you that just in the last year alone, the global interest in EDR is gaining steam. So we'll talk a little bit about where that is, and we'll share with you some additional resources that we encourage everyone to reach out to. And then we'll conclude with a large demonstration of the chain will present, as well as entertain any questions that you have. So next slide. So what problem is EDR trying to solve? Next slide. So as we all know, we live in this world of data, and more data. Just the volume of it, the resolution of it, and one of the challenges that we kept hearing from an OGC perspective within the Metocean Domain Working Group community is a lot of users would find themselves without access to the data that they needed and in a format that they could use that. And so what began a number of years ago as a partnership between the National Weather Service and the UK Met Office was largely then folded into the OGC Metocean Domain Working Group to address these issues and to make data sharing much easier. First, specifically for the Metocean community, but as it turns out, this is really applicable for things beyond just the Metocean community. Next slide. So I don't think the National Weather Service is alone. I think this is a problem for many Met centers around the world, in that we find ourselves with these data silos. So our data comes in so many different formats, like GRIB for us and Buffer, NetCDF, there's XML, and there are a wide range of systems and sources that are used to provide that, whether that's through SFTP, web pages, a thread server, OpenDAP, ERDAP, a bunch of different types of services. And so next slide. If I were to take a visual and apply that to what EDR does, EDR is essentially able to break down these data silos by homogenizing and integrating the data from all those various silos. So it is designed to provide a uniform internet interface and platform where all these disparate formats and systems and sources are all integrated and combined into repeatable, web accessible, structured endpoints. And so then if you go to the next slide, you can kind of think of EDR as this abstraction layer between all of these various disparate data formats, all these different systems, and what a user would see with all these structured and standardized URLs that are self-describing in nature. The EDR is very much a core plus plugin kind of structure, so there's a support for different formats, different coordinate reference systems, interpolation schemes, and what have you. And these structured endpoints and all this support is basically the means to an end. So whether that end is a feature extraction of meteorological information from a coverage collection, or whether it's in the form of a shape, maybe you're looking for a polygon of data, EDR provides that interface for users in a consistent way. Next slide. So how does EDR work? Next slide. So EDR is really a combination of shapes. So we have, through a number of workshops and sprints, been able to account and for any type of observation or coverage data by a variety of shapes, whether that is through a point, multiple points, a point time series, an area or polygon, a cube, a trajectory, a corridor. We can describe any observation or gridded coverage data by one of these shapes. Next slide. The net result is that you get this kind of a la carte service for data. And so as you draw users closer and closer to the data, it really matters, it no longer matters to a user where the data originates or what formats it's in. If a user simply wants a data feature, then we're just serving them that without any of the extras. So this is really interoperability through simplicity. And it becomes essentially like you can think of it as a one-stop data service shop for users in this particular case. Next slide. So as I said, there are benefits for both users and data providers. Next slide. From a user perspective, really, the EDR is designed to lower the bar of entry to data and provide just very simple internet access, browser access to data. You don't need any special software for this. You don't need to concern yourself with these huge data sets. You just really want to receive as much or little data as you want and in the format that you can use. So by doing this, you don't force users from a data silo perspective to be concerned that, do I have a GRIB1 or a GRIB2 file and I need to process that on the back end. You get the data in exactly the format that you want and you don't have to worry about that. So in the end now, users will have a consistent access to all types of data. Next slide. From a provider standpoint, EDR provides a very flexible and extensible framework. The specification can be configured in either the cloud or through on-premise systems. The approach results in a consistent and streamlined and less convoluted data ingest and dissemination process that Shane will describe for you here momentarily. And by drawing users closer to the data, it's quite likely that the amount of data and the response of the data that users will select will be far less than through traditional services today. So you providers will be saving both bandwidth and computer resources for this. And one of our future goals, one of many that we will describe later, but I want to point out here, is the fact that we're really strongly considering the linkage with publication subscription service. One of the main, there are a number of benefits for using this, obviously, but one of the ones that really is important for a data provider is the fact that if you have pub sub, it's quite possible that you will eliminate some of the 404 errors that typically happen from users creating scripts and hammering away at a service until new data is available. So we really feel like this will be a step forward in addressing those issues. Next slide. Yes, so global interest. Next slide. So there are a number of Met centers around the world right now that are starting to use the standard. The OGC EDR API became an official standard in March of 2021. We should be starting to see the publication be made available here. If it's not available now, it'll be available very, very soon. The UK Met Office is probably the group that has put this into production the quickest. I believe this is already being used by operational forecasters. It's still in prototype within the Weather Service, but there are other Met centers around the world that are evaluating this as well. And in just this year alone, NASA JPL, USGS Hydrology, and Unidata for their thread server plan to do EDR implementations by late 2021. More recently, for those of you that are familiar with the World Meteorological Organization, in particular, right now WIS-1, the WMO information system, there is a data dissemination that's been created for 15 GISC global information support centers around the world to exchange meteorological data. And there are a few things under consideration for the WIS-2 technical specification. It's still in draft form that we're focusing on, and that is one, the MOU relationship that WMO has with OGC, and the fact that they plan to strongly consider authoritative web services from both OGC as well as W3C. And there are also some ongoing areas within metadata. The task team for metadata within WMO is strongly considering ways in which to improve the discoverability and ease of use of metadata information in support of WIS2. And that has direct tiebacks to OGC and work that is being done in conjunction with the OGC EDR API group, standards working group, and the OGC API records group within OGC. Next slide. So this slide gives a little bit more background for folks. The EDR website is that top screen there. If there's interest in learning more about the OGC standards working group, there's a link to the GitHub page. A lot of rich information about the EDR specification there, links to different implementations that are in play today. There are 5 active implementations that are in play today. There is also more recently a PyGeo API implementation of EDR that is available for public use as well. And I can get folks the link to that. I didn't include that here. And the last one talks a little bit about the different deployments. So if there is interest in just understanding how EDR works after this meeting, there are links to the direct endpoints for the implementations on that bottom link. And so I would strongly encourage you to look at that if there's interest in that. So next slide. We're going to talk a little bit about the demo. And before Shane does this, I'll just say that what we will largely do is just lay the foundations for the work with search engines and metadata. And then from there, we'll talk about the different ways in which EDR is grabbing information, whether it's an external resource, an internal resource, all the different shapes. And then we'll conclude with some examples of client applications that are making use of EDR in the background, one of which is for the National Blend of Models within the National Weather Service, and one that describes some work with an API process, an OGC API process. And I'll describe that more as it gets closer. So without further ado, unless there are questions, we can turn it over to Shane for the demonstration.
So thanks, Steve. Quick note, just before we pass into the demo, if there is any questions for Steve. Okay, so if there are not anything, then please pass it on the chat box as well, and we'll pick it from there. But I have one quick question, Steve. So the EDR, the way it will work is for the multidimensional data or the raster, right? It doesn't support the feature data set. Is that correct? Or Steve, you're
no, I'm sorry, I was on mute. Yep, sorry. So no, it will support feature-based data as well. And we'll show you some examples of some text products that are really feature-based as a part of the demo.
Okay, great, thank you. So if there's no questions, then we'll pass it to Shane. Thank you, Steve.
Okay. Hey, everyone. My name is Shane Mill. I work for the National Weather Service with Steve. So here's the landing page for the EDR API. There's also a JSON representation of this landing page as well. So if you were writing code to traverse the API, it's all link relations that you can follow to get to the data that you need. But we've developed better and easier ways to access the data you need, which I'll show. So I'm going to start pretty basic here. If I go into this groups area, it allows the provider to organize the data into specific groups. So we have US models, Environment Canada models, NWS observations. This is all just prototyped. If you're a provider of data, you can choose how to group your data together. So if I click on National Weather Service, we have this GFS collection here, which basically this collection is reaching out to the Unidata thread server and basically creating EDR API endpoints based on the data available at that thread server. So if I click on one of these collections, This is for the GFS quarter degree data, and it's grouped into basically weather parameters by common dimensions. So where you see like time and time one, like time is a different time array from time one. So that's just how it's grouped on the thread server. So if I click on this first one, we end up with a collections endpoint for that collection name with instances. So instances, if you're familiar with model data, that could directly correlate to the latest model run or specific model run times. So that's why instances was developed into the EDR API. I'm sure there's a lot of other different use cases for instances as well. In this particular data set, we end up at this collections link with the latest data available with some additional metadata. So you can see here the weather parameters that are available in that particular collection. So if I click on the latest, you end up with the actual data query endpoint here. So you end up with additional metadata here associated to the data contained in the collection. But if you think back to Steve's slide that contained all the different shapes, this is what we mean here. They're sampling geometry types that you could extract from the data set. So I'm just going to show the position one for this particular data set. Here, there's a user interface built into this particular API deployment that if I click on this leaflet map for a point and select, for example, best 4-layer lifted index for a time series, you can see there's a CRS here, output format, and the interpolation method. So this is really just an interface to help you develop a query for the data. So if I click get data here, you end up here with the graph allowing you to visualize the time series. But more importantly, this actually shows the API query. So I know it's small, but you can see basically, if I scroll over just a little bit here, so you can see the collections endpoint latest position and the question mark. So after the question mark are the query parameters that you chose through the interface. Obviously, if you were interested in the same type of data over and over again, the API is structured in a way that you could really just change the query parameters. So like for date time, you could change that. You could not supply date time and end up with the entire time series as well, if that's what you choose. So that's just a quick example of the basic structure of the API. If I clicked enter, you would end up with the coverage JSON output here. So you can see, if you're not familiar with coverage JSON, it's currently being worked on to become an OGC standard as well, I believe. Steve could correct me if I misstate anything there. And here's just the coverage JSON response. It's good because it can handle a relatively large dataset payloads. And it's also pretty simple for an application developer or a user of the data to parse out what they need from this JSON response. So let me back out a little bit here, back to the homepage. I just want to start to incorporate the search engine to the discussion. So, the link relations are good, but it's much better if you could tie a user directly to the data. So in addition to numerical weather prediction model data, we've started to look into satellite data as well. So right now I mentioned Himawari in the abstract, and we're currently prototyping and developing the Himawari data. It's not quite where we want it to be yet, but we do have a NASA MERA data set. So here in the search engine, this takes you to an ATOM feed. The implementation takes PyCSW and creates CSW records for the data, and that's what the search engine searches for. It searches for the metadata contained in these CSW records. As Steve had mentioned, there's a lot of different OGC API standards emerging. One of them is OGC API records, and we eventually want the search engine to be powered by the OGC API records. So this is a metadata endpoint. If I zoom in just a little bit, this should look familiar. It's a collections endpoint. The name of the collection is the NASA MERA all. It's just an arbitrary collection name, but it's for the NASA MERA data. We have the instances and the latest. So this takes you directly to that endpoint I just showed you with the threads that was directed to the thread server. This is actually HDF5 data that we have downloaded and converted to ZAR and reorganized the data how we want it organized for our particular use case. you can see the position, area, cube, trajectory, and corridor endpoints. Again, for this demo, I'm just going to show another position query before I get into the more interesting queries with some of the prototyping we've done with ZAR. So if I do a cloud pressure and cloud temperature query, again, for a time series and click get data, you end up with this visualization of the data. If I copy this into the browser, it would just be a coverage JSON output as well. So the key to take here is, like we're following the same exact API structure, but from two completely different types of originating data sets. One is a download of HDF5 files locally. The other is tied directly to a thread server. So I'm going to progress into one more thing related to what Steve was talking about with features. So if I go back home, the EDR API specification allows us to have these items and locations endpoints, which end up being very similar to what you see in features. So if I search KDCA METAR here in the search engine and go to this endpoint, so you end up with this collection METAR TGFTP /item /KDCA latest. So what this is a METAR for KDCA, which is Reagan National Airport. The METARs are coming from a TGFTP website. So that website is organized basically as text files, and then you have each IKO ID is a specific text file containing the METAR data. So here is the items endpoint, which links to a locations endpoint. So you'll notice here the output format, we have text, JSON, and XML. The originating web source only offers it in text. So the TGFTP website basically gives this text file KDCA and your prototypical METAR. Now, within the EDR API, we try to add a little bit of value here by supplying the data in additional output formats. So we also have a JSON representation of the same exact data. And then we also have an XML representation of the same exact data in the form of iWixSum. So this just kind of shows being able to have similar to a features endpoint, but the add value of having the additional output formats as well. So with that, now I'm going to go more into the details of multidimensional data and how we've organized the data with X-ray, Dask, and ZAR. So I'm just going to give a quick overview of what's going on here before I actually demo it. So with the GFS, we've accessed GRIB data from the Nomad service. So one model of the GFS will have many, many GRIB files, usually organized by time, the forecast time, but that's not always the case. In this specific case, it is. So each GRIB file will be for a forecast time. Now, what I do with those GRIB files is I load them in Python using X-ray as a basically concatenated X-ray dataset object that contains all of the data I need. There's an engine called Pioneer that's no longer being supported in the future, but they also have an engine called CFGRIB, which could also read GRIB data. It organizes the data a little bit differently, so that'll be a little bit of an implementation detail moving forward for how we ingest the data. But either way, we really want this concatenated X-ray dataset containing all the data that we need from these disparate GRIB files. So then we reorganize and bin the data into collections of weather parameters by common dimensions. So what I mean by that is this concatenated X-ray dataset now gets separated out into multiple X-ray data sets. So this first one could, for example, be latitude, longitude, and time as dimensions. The next one could be latitude, longitude, time, and then some type of level in the atmosphere. So you can have isobaric levels, so like pressure levels. The next one could be levels above the ground in meters. So we want each data set to be organized by the same dimensions, pretty much trying to replicate what's actually going on in the atmosphere. Once we have the data in the way that we want, we then want to store that X-ray dataset, each X-ray dataset as a ZAR data store. I put ZAR data store on disk. That isn't necessarily always the case. You could store it locally. What we're doing right now in the cloud is storing it on a Lustre file system. I've seen a lot of documentation on people storing ZAR in S3. You could do that as well. It's very flexible. A really, really cool aspect of this type of data flow, though, is the ability to chunk the data and re-chunk the data. So for example, for a position query, you'd likely want very small chunks because then you want the least amount of data being loaded into memory for a query. And with this workflow, we're actually loading the data lazily. So let me actually go into that. So once we have the data in the way that we want, here's just our backend. It could be on S3, as I mentioned, wherever. Okay, picture this as the EDR API container and the structured URL endpoint somewhere over here. So a user makes a collection query. So for example, for a point, like I showed you. So that's right here. So that you already have the specific collection that you want. So that will be directly correlated to a Azure data store on disk, also related to a collection. So the EDR API is opening that Azure data store. And because of the dash chunking, you're never actually computing the values until you have exactly the data that you need. So we open this Azure data store using Xarray. We have an object, but then we do this sampling using Xarray, and it isn't until you have the specific data for a point or for a trajectory, a polyline, an area, that you actually compute the value. So you're always only loading the data that you need, as opposed to loading the kitchen sink with all of this grid data. Like we're effectively trimming and slicing the data and only computing it at the point that we need the data. So with that, let me give a quick demo. Keep in mind, this is still in prototyping, so everything isn't perfect yet, but you should get a pretty good idea of what we're trying to do here. So if I search for a GFS temperature isobaric, we end up with this collection. We end up with multiple collection endpoints, but I'm going to just use, let's see, the latest 0Z run. So here, this should look very familiar. Again, it's a totally different approach to the data, but the query endpoints are exactly the same. So I'm going to move into an area query now. This user interface should look familiar. Let me zoom out just a little bit and select a big area across the map. We can select temperature for a time range for specific isobaric levels. I'm picking near the surface. And then we have this coverage JSON output. So let me click show data. Okay, so on this leaflet map, again, what's happening is a coverage JSON extraction. So if I copied the link to a different browser window, you would see the coverage JSON. But we want some element of being able to visualize the data before you actually, like go in and extract different output formats and things like that. So we add the ability to, on the fly, do like a color palette as well. So this helps you visualize the temperature data a little bit better, I think. You can switch the times and the isobaric levels as well. So with that, we also have the ability to output in GRIB. So if I click the get data, this is a GRIB file that downloads to your browser. If you're a programmer, you could do a curl command or a wget command as well, and it would download to wherever you're running that command. We have NetCDF as well. And it looks like NetCDF is having issues at the moment, the curse of the demo. But our work with the NetCDF, basically the NetCDF that outputs, we're running it with a CF compliance test. NetCDF could be a little bit open, so we want it to be structured and have some type of compliance towards it as well. So that's what the NetCDF is intended to do. I apologize that it didn't work during this demo. We've also worked on cloud optimized GeoTIFF. So the interesting thing about GeoTIFF is it's typically 2 or 3 dimensions. So if I selected one, like a start time and end time that equal and vertical levels that equal, you would have basically 2-dimensional extraction, which would download just one TIFF file to your browser window. What I've incorporated is the multi-dimensionality. So I'll actually zip multiple GeoTIFF files and send a zip to the browser as well. So luckily that worked. So if I open the zip file, please excuse the naming conventions. It's kind of atrocious at this point, but it's a prototype. These are basically the time deltas and the different vertical levels, but you can see that there's many cloud optimized GeoTIFF files for a multi-dimensional extraction. The one thing I want to mention here too, we've also run this against a cloud optimized GeoTIFF validator as well, and we're passing, we're in compliance. So that's definitely promising. This will be a lot more relevant, I think, to when we move more into the satellite data. I know cloud optimized GeoTIFF is talked about quite a bit with satellite data. So I'm excited to work towards that. But right now for prototyping, you can see it used for the GFS. So I'm going to skip Cube. Cube is basically just an area, but a bounding box instead, but it has the same type of multi-dimensionality extractions there. So trajectory is one of the additional formats that Steve had mentioned. So let me give a demo of an XYZT trajectory, again for temperature. Let me skip that for now. So if I do a polyline across the United States, you end up with these selections of the different waypoints. So here we have vertical levels. You could just pick the different vertical levels you want for each waypoint. So let me do that. And then for each waypoint time, a trajectory in the standard says that time has to be in chronological order. So if I select times way in advance, you'll see the list get a little smaller for the extraction. So let me click Get Data. And here you end up with the trajectory selection. This is in coverage JSON. We also offer it in NetCDF, and the NetCDF, again, is CF compliant. So let me move forward into Corridor. So Corridor, I have just recently started developing within the last couple of weeks. So it's not quite as far as I would want it to be, but I do think I have enough to show everyone what I'm trying to do here. So similar extraction to a trajectory, it's basically a corridor is a fat trajectory. You have a corridor width and resolution. Resolution, ignore that for now, it hasn't been implemented, but if I keep the 100 kilometers of a corridor width and click Get Data, you'll see basically 100 kilometers across of data. If I zoom all the way in though, what's actually happening here is a multi-trajectory query. So if I click this to 500 kilometers, you'll see it get a little bit fatter across the board. So again, this isn't perfect yet. You can see what we're trying to do here, extracting basically 250 kilometers on each side of a polyline. Now it'll get really cool once we could get into XYZ and XYZT corridors, because you could picture like an airplane going across the Atlantic Ocean and being able to basically extract the corridor of that entire flight path 3 times as well. I think that could be a really, really valuable type of extraction that adds a lot of value to definitely a lot of different use cases as well. So that was the corridor extraction. Let me check and make sure I didn't forget anything here.
And then Shane, there's a couple of questions that you might want to just speak to here real quick within the chat window. Take a quick look at that.
Yeah, no problem. Okay. Is all data being processed? Are there methods to redirect users to raw grid message, NetCDF file? That's a really good question. So that comes out to basically how the data provider would want to disseminate their data. So in my opinion, you could honestly replicate a Nomads type of service where you have all the data basically in separate time files. And there's nothing that the EDR API is doing to stop that from happening. Like, don't get confused by like what we're implementing here and what's actually possible by the standard. So to fit your use case, you could actually have methods similar to that items endpoint where you were basically just disseminating the grid messages exactly how they are on the Nomad service. It's really up to the provider. Let's see. Let me share slides. Could you also do time steps as bands and cloud optimized GeoTIFF? So I'm at the very beginning stages of cloud optimized GeoTIFF. I do think you could do that though. I need to read more about the cloud optimized GeoTIFF specification though. But if the cloud optimized GeoTIFF specification allows that, you could likely do that. With a preview color shade done via WMS? That's a really good question, and it actually wasn't. So what's happening here, I'm just going to use this as an example because you can see a color palette here. There's a JavaScript library that reads and displays coverage JSON. And within that JavaScript library, you can set a palette. And the palette can be in different formats. But in our particular case, it was basically a text file containing the hex for each color. Also in coverage JSON, the specification allows you to set a default palette as well. So this is rendering within the browser using a JavaScript library. It's not using WMS, but that's a really good question.
Hey, Shane,
go ahead.
Could I just ask a follow-up on that? So
Sure.
if the data, one of the things that's great about like, data shader, like the data shader.
I'm muted, yeah. This is a demo.
I'm done with this shit. I'm done
Are you
with
there?
Go get a negative COVID test.
Steve, you're not muted.
I got to speak.
Oh, okay.
Can you repeat that question again?
Who am I talking
Sorry,
to?
Richard, go ahead.
Not sure I'm talking to. Oh, there we go. Okay. Yeah. So, if there's like a ton of data that's like too much to deliver to the browser, like a lot of times we have some like, 9 million node like mesh, right? Like, or something, or some massive mesh that, and so like, with WMS or something, it essentially renders on the back and then just delivers you the pixels, right? So are you thinking about that kind of use case too?
Yeah, no, I mean, that's such a good question. I think there's always a balance. So like for these specific use cases, you're basically doing extractions of data that are small enough to be handled in the browser. That may be a situation where WMS simply is better. Like you have a lot of data that you just want to have a server support that. WMS in that situation honestly might be better. The EDR API is good and fits a lot of use cases, but that type of use case, unless you're extracting the data to a low enough level, it may not perform that well for what you're describing. I think a WMS server might perform a little bit better there.
Okay.
So Shane, one quick question, like, you said, like, when you work, you sort of, depending on the use cases, the data chunking you do, right? So like for the data chunking, because the data chunking will be based on your use case. So how EDR is actually working? Because for example, if the data is already provided as a source, right? So as a user of the API, what are the best approach to actually have the quick access to the data sets, especially if you're looking for a long time series data sets?
Yeah, no, I mean, that's a great question. That's something that we need to do more work and studies into how our audience really wants to extract the data. In the cloud, like you could kind of like picture maybe using artificial intelligence or machine learning to figure out how users are querying the data. What we run into here is like, okay, at that endpoint, you have a point query, but you also have an area and cube query. So with the area and cube queries, you would want much larger chunks because you assume that the user is making a much larger data extraction. But for a point query, you want very, very small chunks. Now, if they're almost entirely doing time series extractions, then you would need to, have chunks in the way that, the time series is still wide open. You're not loading a bunch of different chunks in for that time series. You have maybe one chunk for a point that, the time dimension is part of that chunking algorithm that you get the best performance for a time series. So Sudhir, to answer your question, I don't think we've done quite the legwork there yet to truly optimize every type of query, but it needs to happen. And I don't know if that comes into, like having to replicate the data with chunking or having some way to rechunk the data that's performant. We need to do more research there, I think.
Yeah, thank you.
Yep. Okay. I have just a couple more things to show, and then I'll stop talking so we can go into a discussion. So fitting the use case of basically like a point time series, we had colleagues in MDL who were developing this viewer that basically you could select a point on the map. Their application before, if you look at these gray dots, it was limited because it was based on a Postgres database. So every time that someone wanted a location, it had to be added to a database. What the EDR API could do is, like you have this data on the back end, and you can select any point on the map, and it will find the nearest neighbor. So this is pretty high resolution data. It's the national blended models. So if I click on an endpoint here, I'm going to use Spokane, Washington, because all the meteorologists know they're having some record-setting temperatures today and tomorrow. So you can see basically what's happening here is that data query is going out to the EDR API. It's returning JSON, and then this application basically is visualizing that data. So you can see how this application is great for forecasters in the field because you can see, like the different ranges of temperatures based on the model data. So like tomorrow you can see the max T being between 106 and 111. Now this was for the 12Z run today. This is the default setting for the values. If I click all, it'll take a little bit longer to render. Basically for this use case, so we decide to do very small chunks. We decide that there was a little bit, like we want a 1 to 3 second response on any point on the map. And we found that even storing the data in a relatively well-performant Lustre Lustre file system, we were still getting like a 1-ish second lag on opening the ZAR data store in general. So even that 1 second makes a big difference when you're doing a point and click type of application. So what we actually do here is load all of the ZAR objects into memory in the EDR API deployment. And then when new data comes in, we have a process that purges the old data and adds in the new data. So just having that data available in memory as opposed to disk, like allows for a lot of optimization in the time. Keep in mind with the workflow, it's not like we're computing all the values in memory. The data still be loaded lazily, but I think there's just like maybe a 1 second lag in opening the ZAR metadata from the file system. I'm not sure what was causing the 1 second lag, but we found that to fit this use case, the optimization occurred loading the ZAR objects in memory and the small data chunks. One more application, just a prototype I want to show before I open up to discussion, is one of the OGC APIs that are emerging right now are OGC API processes. So I just wanted to demonstrate a way that you could take backend EDR API data and then add a process to it to render new results. So if I select a model runtime for a specific forecast time, for a specific isobaric level, and then extract the bounding box here, this will create a leaflet layer that basically the UMV components of the wind are being translated into the global wind speed and the global wind direction. And then it just uses a JavaScript library to create the animation of the data as well. So you can see like a lot of flexibility. If you have the EDR API as a backend, the structured API endpoints and the metadata within the endpoints, you can populate a lot of the values within an application, but you can also add a process on top of that to add a little bit of value to the backend data. So with that, I'm going to pause. I'm going to give Steve the opportunity to add in anything I may have missed here. So go ahead, Steve, if you have anything.
Yeah, no, I think you covered this well. There are, and this kind of leads into kind of the future work within the OGC EDR API standards working group. Several things under consideration now. One is the coordination with what OGC describes as the family of APIs. So initially, we plan to work with, we are working with API records for metadata. We are starting to work with API processes, and this is an example of how you would link a process service with the EDR API. There's also going to be linkage with sensor things, SWIG within OGC and others. As far as enhancements are concerned, I talked a little bit about PubSub. We are looking at how to use ensembles and the best way to work with that, and that'll clearly be done with a process, an API process service in mind. There are some security-based areas of work that we'll be focusing on, just to name a few of the upcoming areas. So I think that is, yeah, I think that pretty much describes the work. Are
Thank
there
you,
any
Steve.
additional questions on anything?
A question.
Thanks, Steve. I'm looking at the questions.
I have a question about this last slide there with the wind things. Is that was that a standard? Was that the new web processing service API, RESTful API or whatever? Or am I getting that wrong? Didn't OGC, is it they have some new RESTful web processing service or something? Or is that not right?
Yeah, no, I think you're right on track. They have it's technically called OGC API processes. This right now is not technically using exactly that RESTful structure, but I want it to in the near future. We did another prototype during a Pygeo API sprint, I believe, actually, where one of our colleagues from Canada, Tom Carlitis, actually implemented a process within Pygeo API to directly correlate with the EDR API endpoint within Pygeo API as well. So right now, to answer your question, right now it's not using that, but I really want to in the near future.
Okay, and then another question I had from the chat earlier on was, so is this is all, I mean, I understand it's an API, but the implementation of the API that you're showing us here when you were talking about Xarray and Dask and stuff, does that mean that that implementation is backed by like a scalable Python, running on like Dask Kubernetes or something, or it could, or?
Great question. So right now, it's not, but it's something that basically on our backlog right now, that's one of the next things we're looking at doing. We're really interested in making it cloud agnostic, so Kubernetes would be a great tool to use there. But yes, that's a big reason that we decided to go this route, especially with Dask and the ability to, like run these clusters that could be run on different instances and things like that. I haven't done enough of the legwork and the research there, but it's something that we're aiming at doing in the near future.
So, but it is Python though, right?
It is Python. Yeah, the implementation is in Python.
Yeah, you're just running it on an EC2 instance or locally or something?
Yeah, so right now it's on one EC2 instance and it's on one Docker container. So like the first step here is I want to separate out different components and build it probably with Docker Compose. And then, there's a lot more that can go on to make it scalable. I think storing a lot of our data on Lustre though, like our aim there is that, potentially you can have multiple instances hit that one Lustre file system. So we have scalability in mind right now, but we could do a lot of work in making actually implementing a scalable architecture.
Yeah, you're all set up for a scalable infrastructure, right? That's awesome.
Yep.
One other thing you may want to raise attention to is, and I'll speak to this just a little bit, but you can amplify on this, Shane. There is a USGEO NOAA NASA initiative on low Earth orbiting satellite data and the discoverability of that in a cloud environment. And as part of the phase 2 study, they're looking at EDR as the back end for work with GOES satellite data and Himawari satellite data, and to be able to use the UI interface not only to pick and choose specific areas of interest, but to output the data in cloud optimized GeoTIFF and GeoTIFF formats. So that's another area of prototyping that will be going on. That's started, but we're still in the beginning stages of this. And Shane, I don't know if there's anything more you want to add to that.
Yeah, just a very quick thing to add. I think it's interesting to go through this prototyping, especially with the cloud optimized GeoTIFF. I think there's a lot of people out there who are trying to do very similar things to what we're trying to do. So with cloud optimized GeoTIFF, it actually ended up being much easier to implement than I thought it would. There's this Python module called DataCube that works directly with Xarray and has a cloud optimized GeoTIFF function that I could use directly. Some of you may be familiar with Rasterio as well. I couldn't find proof. There's basically this function that could write GeoTIFF. I couldn't prove that it was writing cloud optimized GeoTIFF. So I skipped out on that for right now, but I could always use a validator to see if it is or it isn't. So yeah, I think there's a lot of people doing similar things, and it's good to not have to, reinvent the wheel. Like we're using a lot of existing open source technology to power this.
Cool. Hey, thanks, Shane. Thanks, Steve. So any question for Steve and Shane? So I see like Ryan is trying to figure out like, what where the folks can go and look at the EDR specs and try some of those. Is there any locations that is, if there are, we should share those locations in our notes as well.
So there were the links that I provided in the last slide that would be good starting points for that. We are also in the process of creating a best practice, an OGC best practice document within the OGC EDR API SWIG, and so some more material that we've certainly been generating for our czar Xarray Dask environment will go into that best practice document. If there's interest in that information as well, we can certainly share that with this group.
Yeah, that would be great, Steve. So we definitely like, and thanks for sharing, Steve, the presentation. So I'll upload those presentation and share with the group as well. Well, one quick question from me, if there's any, is also like, you talked about the Shane, you talked about the data cube. You say you have still working on it. Can you give some sort of a little bit of highlight what kind of data cube you're working on?
I wonder if you were you referring to the data cube Python module I just mentioned with cloud optimization? Yeah.
Okay.
So that's actually, yeah, that's just a Python module.
Okay, that's a Python module.
Shane, do you have to do you interpolate then if you've got a if you've got a projected grid like Albers or like some of these models are in some kind of projection, right? Like, do you just write in that projected coordinate or?
Yeah, that's a great question. So right now, like what we're doing is we're only supplying the native projection right now. The infrastructure of our implementation, we really want like a core plus plugin approach. So what I visualize that as being is you want these transformations to occur, and I want like almost a generic way to do these transformations. That can be challenging though, because there's so many different coordinate reference systems. So, I mean, you have to start somewhere though, but what you're seeing right now, nothing is being reprojected, but that needs to be something in the future.
And this, I don't know, so here, do we have to stop exactly at 2, or can we just kind of like let people drop off and keep it going for a little bit?
So Rich, if it's okay with you, I could make you, or Sudhir, I can make one of you host, and you're fine to keep going if you'd like.
Sure. Well, we can stay a little bit, but the folks, if you want to drop out, you can. We'll stay a few more minutes if you need to.
Yeah, because I mean, yeah, this seems like really fascinating. And
Cool.
Yeah.
So I think there was one quick question, I think from Ryan, right? Ryan, you talked about some of the work on the NESDIS is trying to pilot. Is that correct? Is it you and Ryan who talked about it? Because I saw in the chat. NESDIS is currently piloting rework of holistic NOAA archive and access in the NESDIS Common Cloud Framework. So it would be useful to see how to use your spec so it can be evaluated against other similar efforts we're working at now. But I don't know who said that. Yeah, thank you, Megan.
Sudhir, it looks like Ryan dropped.
Okay, all right.
So, so this is, I mean, this is really cool. I mean, I know that, like, on the Pangeo project, which I'm sure you're familiar with, and we've talked about quite a bit here, that project has been sort of going right to the data, right? Like bypassing services and just going right to S3, and sort of from the point of view of, trying to, scalability mostly, I guess, and performance. But there's always been talk about like putting an API, like putting maybe the OpenDAP API or something, on top of Xarray, backed by the same kind of scalable, Dask Kubernetes or whatever, maybe Lambda in the future. And this seems like this is it though, right? Like this is sort of the API on top of that whole Python scale, flexible ecosystem that could be scaled out, right?
Yeah, no, I think you're right. I think that the good thing here is that it's backed by the OGC too. So we're not creating like another silo here. But yeah, you bring up a really good point. I remember Steve and I had a meeting with Ryan Abernathy, who's so heavily involved in ZAR and Pangeo. And he was talking to us about, I think there was an API developed called XPublish.
Right.
And that to me seemed very similar to what we were trying to do here. I never used that or added it to my implementation here. But I think, yeah, I think wholeheartedly things are very aligned.
Yeah, because that was just
what Pangea is trying to do. Yeah.
Yeah, because that was just an example. I mean, that was just an example of saying like, hey, you could do this. Like there wasn't a whole lot behind the XPublish, right? It was just sort of like saying like, hey, you could put a service on top of this whole thing, and that's what you've done essentially, right?
Yeah, no, exactly. And I think like the good thing about the EDR API specification too is, yeah, like you and I are very interested in this multi-dimensionality, access to data with ZAR and scalability and everything like that. But I think a key thing here too is like that's up to the provider and the implementer. Like you don't have to do that either. You know, like you could access the data in the same way with a totally different backend infrastructure.
Right.
So, but I'm with you. Like what you're talking about right now is specifically what I'm heavily interested in too.
Yeah, one thing sort of like, fascinates me, or sort of like a challenge is also like, how we are providing the, large data sets chunking into the web, right? Because, and if I understand correctly, Shane, so the API that you have that can sit on the back end for querying or providing the data, but someone can write the, JavaScript API on top of it for the applications for UI.
Yeah, you could always do that. Like a lot of the clients I developed, like that specific application honestly needed its own API to really operate well too. So one example is we prototyped like a way to access GFS data through an application, like basically nomads. We tried to prototype nomads, and with that application, you basically had to use a client application because it needed multiple EDR API requests to fulfill one request. But if you develop the application well, we used like G Unicorn for the request, so you can handle a lot of concurrent requests and things like that. I think a lot of times, like in an application, you need to develop an application specific API, but there's no problem in reaching out to the EDR API to do that.
Okay, that's cool actually.
Sudhir, this is Brian Moretsky from the Weather Service. I just wanted to say to Shane and Steve, a great presentation. And I look forward to following up with Shane and Steve and Sudhir on some Weather Service discussions and how this all applies. But I think this is a great presentation, so I really appreciate it and letting me sit in.
Oh, thanks, Brian, for joining.
Yeah, thanks, Brian.
Yep. And we'll keep in the show probably looping because this is our monthly presentation that we have every month. So probably like other folks from the GIWT can also join from NOAA side. So glad you could join.
I got more calls, so I got to drop. Sorry, but thank you.
All right, thank you.
Looks like Peter wanted to say something.
Yeah, I was just thinking, you spot me muting and unmuting there. I was just thinking it'd be really interesting to connect EDI with process and run them in Kubernetes on Pangeo, and then send the data that we're retrieving into a Jupyter notebook and stick it on a leaflet map using PyLeaflet, wouldn't it? And that would sort of close a lot of loops. It would do the sort of the analysis person and the sort of the data presentation or forecast and meteorology type person both at the same time, wouldn't it?
I think that would be great, especially the Jupyter notebook aspect. We've talked about that a lot with the EDR API swag in general. Like we need ways to help implementers implement something like this, and like a Jupyter notebook is the perfect way to do that. And yeah, definitely the relations you talked about there. I think that would be amazing to be able to connect the dots in that way. So I fully support that.
Yeah, and it sounds like we're very close to that, right? Like, with a slightly
Yeah.
different implementation on the back end, we would have it.